What is a mineral? Well, let's start with the basic building block for all earth materials, which are atoms. Atoms consist of three basic components: protons, which carry a positive charge; neutrons, which carry no charge. Those join together to form the nucleus, and the electrons carry a negative charge and they circle the nucleus. Atoms combine to form elements. Elements combine to form minerals. We have well over 4,000 minerals on Earth. A few of these are called native elements that are made of only one element, but most minerals are combinations of elements. These are some examples of native elements formed of only one element. We have gold, silver, platinum, diamond, graphite. Notice that diamond and graphite have the same element, carbon, and sulfur and copper. They're only one element. This chart should seem very familiar to you. It's on the front cover of your ESRT, and it talks about the average chemical composition. If you look at the percent by mass and in the Earth's crust, you'll notice that the two most abundant elements are oxygen and silicon. If a mineral has these two elements, they are called silicate minerals. It's a huge group of minerals. There are four main mineral characteristics or criteria to be considered a mineral. The first one is it's a crystalline solid. That means that the atoms keep their form at room temperature, and those atoms are arranged in a crystal structure. The second criteria is that it has to be naturally occurring, meaning it cannot be manufactured or made by man. So, for example, a diamond is naturally occurring. That is considered a mineral. But a cubic zirconium is made by man. That is not a mineral. The third criteria is that it has to have a definite chemical composition. That means it's a distinct chemical makeup with a specific chemical formula. The fourth characteristic is it has to be inorganic, meaning it cannot be made by living things, which means that's organic. There are two ways that we get minerals. We get them when they crystallize from magma or lava, meaning the lava cools to a solid and it takes a crystal shape. The second way is that it precipitates out of the solution. For example, if I have salt water and it evaporates away, leaving the salt crystals, that is the precipitate, and that's the second. This slide shows you how we get crystals from the magma. It starts to cool, you get the growing crystals, which are the different minerals in the magma and lava, and they fill up and cool until they're completely cooled, and then that is when it becomes a crystal and is a mineral. The second way is you do have this ions in solution, and eventually they could precipitate out by a chemical reaction, or they precipitate out because they evaporate away. Either way, it leaves you with a solid crystalline structure. We are going to be identifying minerals by their physical properties. Let me say that the crystal form or that crystal structure does determine the physical properties. And the physical properties we are going to be looking at are color, streak, luster. And we have two types of luster, metallic or non-metallic. Hardness, which we will be using a scale called Mohs hardness scale. Cleavage, fracture, or an acid test for the carbonate minerals. As I said previously, a mineral's physical properties are controlled by this crystal structure. This will become the mantra for physical properties of minerals. the internal arrangement of atoms. If you look at this diagram, it's showing you a repeating and orderly pattern. This repeating and orderly pattern, it's a geometric arrangement of atoms, and it's held in place by bonds. We're going to look at a few examples. These are just a few of the geometric shapes that crystal structures take. The top one is called a cubic crystal shape. An example of this is halite, better known as table salt. You'll look at the bottom is a rhombohedral crystal shape of calcite. It kind of looks like a warped rectangle. On the back cover of your ESRT is the mineral page. Under distinguishing characteristics, it gives you a lot of the minerals' crystal shapes. As I said earlier, the most common crystalline structure is the silicon-oxygen tetrahedron, because that is the most common elements on Earth's crust. And it is the basic building block for silicate minerals, and it can be combined in many different ways. 25% of all minerals are silicate minerals, and this silica tetrahedron can be ordered in different ways, which I'm going to show you on the following page. These are some of the many different crystal structures that the silicate tetrahedron takes. You could have a single chain, you could have a double chain, you could have a sheet structure, or this bottom one, the framework silicate structure of quartz and feldspar, really makes that a hard mineral. When we were talking about the native elements, we talked about diamond and graphite. They have the same chemical composition, carbon, but because they have a different crystal structure, they have quite different physical properties. We are going to be looking in the next slideshow presentation about these physical properties. And know that bonds, weak bonds, and strong bonds will be considered when we talk about the crystal structure.